So the next thing we got to tackle on this thing are the axles. You might have seen on my 914 video that the biggest challenge with getting this engine to work properly in the back of a car is the length of the whole thing, because you have to have a separate differential or something to transfer the power from the output shaft of the transmission to the wheels. And what I did on this one is I have this diff here and I have axle coming out of it, but I jammed it as far forward as I possibly could because I was totally committed to being able to close my deck lid fully. What I've encountered is at this angle right here, these keep breaking. As you can see, this axle has seen better days. The ball bearings are out of it. It's trash. So, and that is all because this angle is too steep right here. And this one broke entirely, so I had to remove it. But you can see it would be going from here. You can almost see the axle cup right there. So from the stub axle right there to here, it's a very steep angle. So what we're gonna have to do is we're gonna have to move this whole powertrain rearwards by a set amount. I need to measure right quick and see what that amount is, see how far I'm willing to push it back. I won't be able to close the deck lid anymore, but I don't want to have it hanging totally open, so we'll see what the measurements are looking like. So I just measured, and this thing's gonna have to move 6 inches to the rear. So the deck lid's gonna sit something like this, which isn't perfect. I don't love it, but it's worth it to have a reliable car that doesn't snap axles every 100 miles. So in order to do that, we've got to have new engine mounts and a new diff mount. And so the engine's got to come out so that I can measure these mounts, design them in CAD, and get them laser cut. So this is going to be interesting. I've removed plenty of Beetle engines. Super easy, 4 bolts and some wires. I never totally removed a finished build from the car before, so we're going to see how easy it is compared to the Beetle. I think it actually won't be bad at all. So first step is these exhaust pipes, just wiggle them until they pop off. Then we got the choke right here. Just need a Phillips head. This is just a choke cable off of Advance Auto's website. We got some electrical connectors. There's a coolant temperature sensor right here, and there's another, this is the IAT sensor plug here. We got our coolant temp for the gauge right here, and just a 10 millimeter ground. Funny how, I mean, there's always improvements that can be made, right? I'm looking at all this thinking, this go around with the 914, and if I got the opportunity to do this car again, I would do things differently. But you know, there's something to be said for doing a dry run to see if things work before you throw all your money at it and all your time, and I've confirmed it works. So time to throw all the money and time at it with the 914, and maybe with the next Beetle I do, if I do another one. So this is the plug for the pulse generators. Unplug that. These are the gear shift sensors, so it'll tell you whether you're in, well, it'll tell the ECU what gear you're in, and it also gives you a neutral light with one of these plugs here. I'm gonna replace these connectors because they were cheap. Surprisingly, no corrosion in them though. Interesting. They did pretty well for what they are, just cheap little Amazon things. And they don't come apart very easily, so I'm gonna just cut them. A bit of water gun in there, need more heat shrink this time. Okay, so when we put all those back on, I'll just use some open barrel splice connectors and splice those together and heat shrink around them so we keep moisture out of there. Overall, it seems like things are holding up pretty well. I think for the next things, we gotta go underneath. So the next thing is the shifter. So I've used a push-pull cable here for my shifter. This is a rudimentary setup. What I would do instead this time, and probably will do, is use a ball end linkage that just has a ball joint in here, and it'll be much more flexible, much tighter as well. It'll allow more travel, but also zero slop, which was a challenge with this. The shifter had some slop, so we'll correct that this go around, but I just took the nut off of there. Then we gotta undo that nut right there. She's a real big one. So this bracket here is attached to the engine mount. And the way to remove this is not to remove the mounts from the engine, it's to undo the mounts from the frame horns, which I basically replicated the way the transmission and the engine mount in originally. Okay, now we're on the other side of the engine. We better go ahead and undo the clutch cable. Then we go inside the car. And we got more electrical connections. The one I was talking about for the ignition coils. Battery terminal disconnected. We'll go ahead and do the power from the alternator. I think that's just a 10 mil if I remember correctly. Here's another thing we need to fix is I lost my filter for this crankcase breather, so we need to put a new one of those on there. And we need to disconnect the starter cable. Then the throttle cable, which is honestly the most fiddly part of this. Not too bad, but it's definitely the part you don't look forward to. You gotta figure out how to undo these nuts without really entirely seeing them. Alright, here's where things get a little messy. Hopefully a little messy and not a lot messy. I haven't run the fuel pump in a few days, so this line could be totally clear of fuel. That would be nice. I don't really want to smell like gas, personally. As I hoped, no gas. Now time for the coolant hoses. There are two main ones on the engine, this one and this one here. Gonna replace this with an aluminum tube so that we don't get any kinks like this. Alright, now it's time to get really real. We need to take our specialized tool, aka motorcycle jack here with a piece of wood on it. Fortunately, we're gonna get some coolant dripping onto everything, but just kind of how it goes, I suppose. So jack it up. Okay, so first thing is these right here, one on either side. They mount to the bumper mounting points. See it drop down, it's free. Now the final two bolts are very much similar to the transmission mounts. I made these, left these open-ended on the end because the bolt is in here. So you need a really long extension and the right size socket. It's 21 millimeter. Take one of these, start undoing it. Three bolts for the diff, and it seems like it loosened up considerably. The whole thing just shifted like that, so that's gotta go down. Went ahead and just traced each of these out of cardboard. Then I laid them down on some graph paper, took a picture of the graph paper with the cardboard cutout on it. And since I know the width of each of these squares, the width and the height, I just scaled the image relative to the squares, and that way the dimensions for these mounts on my screen on the CAD software are correct. Then I went ahead and traced the dimensions and cleaned up everything because, like I said, jagged angle grinder edges before. Everything's nice and smooth. So I did that for each of the engine mounts. I also did that for the diff mount, for the body mounts, all of that. So we have mounts in CAD. Then I went on over to Send Cut Send to get these things laser cut. We're going to use Send Cut Send this time and not the angle grinder over there because we're doing this professionally. We are going to use state-of-the-art modern day technology instead of taking 10 million hours on the angle grinder and then still getting jagged edges. These are going to look great. A few days later, I come outside to a nice little rush order from Send Cut Send, and they did a fantastic job on these. They just laser cut them. But I tell you what, it's really nice to have professional looking, nice straight edges on parts. So these are replacements for one of these. I want to say it's this one here. Huge thanks to Send Cut Send. They're fantastic. Love them. One of the best services out there. If you need something cut, you need something CNC machined, whatever you need related to cutting metal, check out Sin Cut Sin. They got you. So now all we got to do is weld the mounts together like that with those parts just 6 inches longer, which should be pretty easy. I went ahead and did a test piece, and you can see I started out, I started out here. This was really hot, as you can see, metal turning blue and a little spattery, so voltage too high, turned the voltage down a little bit and got this, turned the wire feed down a little bit, and I think it was one of these, probably this one. The penetration on that, I think, wasn't quite good enough. Oh, it was this one here. Penetration wasn't quite good enough. So I went in and cranked it up just a tiny bit more and ended up with this right here. Good penetration on it. And also I chose this over this because you can see the blue surroundings of the weld. This is called the heat affected zone, and you want to keep that as small as possible because it results in brittle metal, which we don't want. This one, it's kind of hard to see because everything was real hot at that point, but you can see based on how this is not quite as dark blue as this is, which I welded first. This position is fixed on the car. So this is going to end up moving 6 inches this way, which puts it about here, which ends up being about here. And you can't come up from there through the exhaust, so we're gonna have to have 4 of them, one here, one on the back side of the exhaust for each side. So I need to cut 4 of these. Okay, so we got it clamped in. Now we want to leave a mark at 12 o'clock on here because the other side's got to go around another round tube, so there has to be a notch cut into it, a radius cut into it to go around that tube, and we need to know which part is the side and which part is the top. So I got those cut and welded to each of the mounting plates for this rear part of the mount here, and you can see why it was important for me to make this mark. I said it was 12 o'clock. When it's attached to the actual mount, it's actually 9 o'clock. But it's important for me to make that mark because it's kind of hard to tell where the 5 degrees is. If it's this way, that way, which angle is it? So you make that mark and then it's easy to just clock it appropriately on the mount. Also in the process, what I had to do, this was the same as that. I had to cut this into a particular weird shape because I've moved 6 inches rearward, and 6 inches, if I used that original mount, it would be poking out here, it would be sitting here, and I can't have that. So what I did was I cut it up, notched it up properly so that it can sit here. You'll see once it's on there, I've cut it so that it won't poke outside of this this cutout for the bumper. The next thing is each of these tubes needs to be notched at the end to accept a perpendicular attachment to another one of those tubes, like so. Now, last time I just freehanded this and it turned out janky because I had to fill in the whole area with a bunch of weld because there were a bunch of weird giant gaps. So this time what I'm going to try to do is make a template and just cut out the correct amount of material from this cardboard and then slide the sleeve over another piece of tube draw out the curve that I need and then angle grinder it out. All right, so I made my template. Fits nicely around a tube. So I want to cut a notch out of this one here. I'm gonna do is slide it on, take the marker and just go around here, and then that tells us where we need to cut. All right, that took forever, but I finally got the mounts welded up so that they hold the engine into the car and that all the mounting holes line up. Turns out that by moving it 6 inches back, it changes a lot of the geometry. So it wasn't just a straight up plug and play situation, move everything 6 inches and repeat exactly as I did before. The mounts are quite different. So what I did was I went ahead and traced them out. Then I can just get something of this form factor cut out from Cut Send after I put this in CAD and not have to have a bunch of pieces welded together. I'll just have a single piece of sheet steel. So they'll look a lot cleaner in the next iteration, but this will work. It'll be strong enough. Pretty excited. Coming along. All right, so next thing we need to figure out is the shift linkage. Originally, there was no cross member here. So the push-pull cable that I use to control the shifter could just run down the side here, but it's gonna hit this, so it can't do that anymore. And I also had a pretty rudimentary setup here. I had the original Goldwing shifter with a little tab welded onto it for the push-pull cable to slot its threads into. And as you can imagine, that created a bunch of friction. Just pulled this off of the diff. The carnage. So the next thing to work on here is the diff mount. So I got the diff on the engine here, and we got this plate here, and then we're gonna have a square tube running this direction welded to this plate, and then we got another plate here that goes like this, and then there will be a tube running this direction that will run to those mounting points where the transaxle would bolt up. Ultimately, it'll end up a lot like what I was trying to do here, but it'll actually be executed properly. So the diff mount is done. Honestly, it was not that hard because I already had the dimensions from the previous diff mount and they all went super well, except for this. I had to add a notch for a little, for the drain plug on the diff. But other than that, went really smoothly. It was just a lot of welding. But I must say, my welds are getting better. They're getting better with each weld. Starting to look more and more professional. Making progress every day. Okay, it's in there. We're back at the original point of this whole redesign, which is trying to get the axles in here at an angle that they won't keep breaking CV joints.